In today's video, we'll be looking at multiplying rational numbers. In the previous video posted, we were looking at multiplying integers. So there will be very many similarities and differences between the two. And there will be a few rules that we have to remember from previous years of math and videos about multiplying fractions and decimals. But to start, let's look at our rules for multiplying integers and therefore multiplying rational numbers. When we have the same signs, that gives us a positive answer. So for example, if we had 3 times 3, both positive, that would give us 9. If I had -5 times -6, both negatives, that gives us a positive 30. Our other rule states that if the signs are different, it gives us a negative answer. So if I have -2 times +4, I would get a -8. And conversely, if I had +7 times -9, I would get a -63. Okay, so those are our rules for multiplying integers. Now, one thing we did do was to look at a method called the Tic Tac Toe Method that helps us keep our answers organized with positives and negatives. And the Tic Tac Toe Method simply starts by drawing a tic-tac-toe board and then filling it in with positive and negative symbols. So our positive symbols fit on the diagonal from the upper left hand to the lower right, and our negatives fill everywhere else. Okay, and we think about it as this is the first column is our first number times the second column equals the third column. So if I had -3 times 4, I would find the -3 or the negative, followed by a positive, and I would see that that equals a negative. So this would be -12. We will use our tic-tac-toe method. I encourage you to write it down now before we move into our examples to solve. So I encourage you to pause the video and copy down this tic-tac-toe board. Okay, so let's look at our examples for multiplying fractions. There's a few rules that we have to remember. The first is that we multiply numerators times numerators and denominators times denominators. And the second is we might have to simplify once we get our answer. Okay, so we see 1 times -2. Well, I think to myself, 1 times 2 is 2. A positive times a negative is a negative. Then I say 3 times 9. Well, 3 times 9 is 27. They're both positive, so this is positive. And I have -2 over 27. Now, it doesn't matter where the negative is. It can sit in the numerator. It can sit in the denominator, like so, 2 over -27. Or it can sit out in front in between the two. Okay, -2 over 27. These are all the same answer. Generally, what you see though is a negative in the numerator because this can get confusing. It looks like the negative might have been just drawing my fraction bar line weird. And you do see a negative in the denominator, but it is not that common. Let's look at our next example. 2 times 7 is 14. 5 times 10 is 50. I have a negative fraction and another negative fraction. So a negative times a negative makes a positive. And the only thing we have to do is simplify. So what can I divide 14 and 50 by? Well, I know they're both even numbers, so I'm going to divide them by 2. So 14 divided by 2 is 7. 50 divided by 2 is 25. This was a positive, so this will remain a positive. Okay, our next example, negative 3 over 4 times 8 over 11. And now I'm going to start showing you a trick of how we can simplify at the beginning of our multiplication rather than at the end. The other difference is we see multiplication represented by parentheses. So there are three main methods to represent multiplication. We can use the X to show multiplication. We can use the dot, and we can use parentheses. So this is using parentheses, but it still means to multiply. So let's look at the method to simplify. Now I can see I have 3 times 8 and 4 times 11. But I notice I have an 8 and a 4. Well, I know these are both, 4 is a factor of 8, 8 is a multiple of 4, so I can reduce early. And we do that by dividing the 8 and the 4 by the same number. Okay, so 4 divided by 4 is 1, and 8 divided by 4 is 2. Okay, now the big thing about this is we can only multiply we can only reduce numerators and denominators. We saw over here with the 5, we can't divide out the 5 with 5 and the 10 with 5 because they're both in the denominator. This only works if you have numbers with common factors and one's in the numerator and one's in the denominator. So now let's continue. 3 times 2 is 6. 1 times 11 is 11. We have a negative times a positive, so that makes this negative 6 over 11, and this is already simplified. So a good way to save yourself some extra work is to simplify at the beginning. We have a few more examples with fractions before we look at decimals. So let's look at this first problem, 1 over negative 2 times 2 over 5. Okay, I can see I have a 2 and a 2, 1 in my numerator, 1 in my denominator, so I'm going to cancel. 2 divided by 2 is 1. Negative 2 divided by 2 is a negative 1. Now I'm ready to multiply. 1 times 1 is 1. Negative 1 times 5 is negative 5. Okay, we have 2 more examples. So I have a negative 3 over 7 times 7 over 12. Well, I already see I have a 7 in my numerator and a 7 in my denominator, so those can cancel. 7 divided by 7 is 1. 7 divided by 7 is 1. I'm going to check the 3 and the 12 just to make sure, and I do see that I can divide 3 into 12. 3 is a factor, so 3 divided by 3 is 1. 12 divided by 3 is 4, and I've taken all of my numbers but 1 down to the number 1, so this is going to make this much easier. 1 times 1 is 1. 1 times 4 is 4. A negative times a positive is a negative. Okay, and our last fraction example. So I'm looking at these. I have negative 5 over 8 times negative 7 over 11. 5, 7, and 11 are all prime numbers. That means they're only divisible by 1 in themselves. And none of them are factors of 8, so this one won't be simplified, so I simply multiply across the numerators and multiply across the denominators. So 5 times 7 is 35. 8 times 11 is 88. A negative times a negative makes a positive, so this is 35 over 88. Okay, let's look at our decimal example, and then we'll wrap up the video. Okay, so with decimals, this is a bit different. You can use a calculator for both of these, but I'm going to continue to show you the longhand method. So remember, we need to multiply our decimals. And unlike when we add or subtract decimals, they don't have to be lined up, but it is important where we put our decimal at the end. Okay, so 4 times 3 is 12, carry my 1. 4 times 2 is 8, plus 1 is 9. I'm going to mark out what I carried. 1 times 3 is 3, forgot my placeholder 0. 1 times 2 is 2. I'm going to add. 2 plus 0 is 2. 9 plus 3 is 12, carry my 1. 1 plus 2 is 3. Now, to find out where the decimal goes, I count every number in both factors that's behind the decimal point. So 3 and 4 are both behind decimal points. That's 1, 2. So I have 1, 2 numbers behind my decimal point in my answer. This was a positive times a positive, so I have a positive answer. Next one, 0.5 times negative 0.4. Well, I already know what 5 times 4 is, and that's 20. So I would count, I have 1, 2 numbers behind decimal points, so 1, 2. Now generally we don't just start with a decimal point, we put 0 at the front. So 0.20, I have a positive times a negative. That'll give me a negative answer. And our last example, negative 2.1 times negative 4.5. So 2.1 times 4.5. So 5 times 1 is 5. 5 times 2 is 10. Placeholder 0 because I'm moving from the 10th place up a place to the ones. 4 times 1 is 4. 4 times 2 is 8. We're going to add. 5 plus 0 is 5. 0 plus 4 is 4. 1 plus 8 is 9. I have 2 numbers behind my decimal point, so I have 1, 2 in my answer. A negative times a negative makes a positive, so this is a positive answer. And that is how we multiply rational numbers when integers are involved. Thank you for dropping by. I hope you enjoyed this Math with Miss V video and that you check out all the others that I have. Have a great day.